this lecture, we are going to learn about tree traversal. So how can we traverse a tree such that we can travel all the nodes of the tree? So unlike linear data structures like array, linked list and queues or stacks, whichever data structure that are linear have only one logical way of traversal. Okay, so you can just linearly traverse a linked list, an array and so on, but trees can be traversed very differently because at each way you have two options. Okay, in fact for a binary tree I'm talking about. Okay, so here I can move to this direction, then again from 6 I have two options, moving to 3 or moving to 7. So it's not that easy. Okay, so as it's pictorially depicted, so array you can just move in one direction. Okay, that's there in a linked list also, from node 5 to node 34, 34 to 23, 23 to 1 and then to 8. Okay, so this is the simple way. You don't have multiple branching options. What happens in a tree traversal? Okay, so as we discussed, so we have three major different kinds of tree traversal methods. So first is in-order traversal, next is pre-order, and the last one is post-order. Okay, and in this lecture we are going to concentrate on the in-order traversal. So this uses the power of recursion. Okay, so it's a very simple and small code, and you even have 10 millions of nodes in a tree or 1000 nodes in a tree. This recursive code is going to traverse all the node. Okay, and when you are just a beginner in computer engineering, you will find this code quite amazing. Okay, that how is this 3-line going to handle such big code? At least I did. Okay, so to start with this code, we will give it the in order, we will call with tree.root. Okay, so I will pass the function, the argument, the node of the root of this tree, so this 15. Okay, and then we will see how this code works. So it says that in order x, okay, so it takes an argument x which is a node, and if x is null, then what we do, we just return. If x is null, it comes here and returns. But if x, the node, is not null that we are traversing, so first we traverse in order x dot left, so we go to its left node. Then what we do, then we print the key of the node, and then we traverse the right node. Okay, so this is as simple as this. Now what happens, so let's try to trace it so that it becomes easier for us to understand how it happens. And for recursion, to understand recursion, it's always very helpful to understand one concept. Okay, that when we call recursive functions, or when you call functions, so this is a stack. Okay, and when we call, so stack in order, so I will make a short form I, and on the stack these functions are pushed. So if I'm calling in order, and from here I call function f1, so f1 will be pushed from f1. If I call f2, f2 will be pushed onto the stack. If from f2 I call f3, f3 will be pushed onto the stack. When f3 returns, it will be popped out from the stack. Then f2, when it returns, it will be popped out from the stack, and so on. Okay, so first what happens, I call in order with node root, which is 15 here. Okay, so I call it I15 as argument. Okay, so next let's see what happens. Next what we see is that we have now I15. Next what happens, in order x left is called, because 15 node 15 is not null. So what will happen is that we will call x dot left. X was 15 here, so I called x dot left, which is 6. And then what happens, 6 is called, and then from here we have now in order x dot left, and I have given line numbers 1, 2, 3, 4, which are represented here. So in now it keeps we keep some information. So I had initially called in order with node 15 as argument, and in that I had processed line number 2 and I called in order x left, so I something was pushed onto the stack again because I called in order with node 6 as argument. Okay, next let's see. So from I6 again it is not null, this node 6 is not null, so it calls in order x left, so which is it calls I3, the node 3, and it is at L2. So this is I'm storing that okay which function was called and at which line it had called some other function. So now it calls I2. Okay, so I2 is called and I3 also stopped at line number 2, so in order x left. So I2 was the node 2 was the left child of node 3 as it can be seen. Next what happens, from 2 x is still not null, node 2 is not null, but when it tries to call its left child, okay, in order x left, so it finds that it is null. Okay, and when it is null, so if x is null, it simply returns. Okay, so it returns to 2, node 2. Okay, and now it was till line number 2 it had already executed, as can be seen from this data history. Okay, and then it goes to the next line L3, which is print the key, and key here is 2. Okay, so first output comes here, which is 2. Next what happens is that now again I2 it has printed, and then it calls in order x right. X right for 2 is also null. Okay, so null, it's again null, so it just returns from there. And now what happens, I2 is done, so I2 was done, and now I2 was also, it had executed till line 4 and there was nothing. So next time it returns and I2 is popped out from the stack because everything is done, and we are now at I3 and I have executed its left part. So in order x left has been done, so we are here. So keep track of from the tree also, so we have this. So here now what we do, I was at line 2, I will print. Okay, so now what will I do, I will print x dot key, so 3 is printed here, and then now my line number has also changed. So I3, I have executed this line, now I am executing L4, and if you execute L4, so what happens is at I3 I have executed L4, okay, and I come to I4, okay, and at node I4 I am at L2. This is not null, so in order x left, but it will be null, so it will just return back. So I am not shown it again here. And then what will happen is right also it will execute x dot right, but it will print the key. So 4 is printed, and then it calls in order x right, so that will, okay, so here a few things are happening. Okay, so at 4 it first called x dot left, which was null, so this line was executed. Then it printed 4, which is printed here. Then it called x dot right in order null, which just returns back to 4, and from 4 I4 was here, so it now returns, so I4 is popped and it goes to I3 from where it was called, and I3 also now was at line 4, line 4 was also completed, so I3 will go to 6. Okay, so this way now let's try to look, we are at 6 and I3 is also popped out from the stack. I am at 6, line 4 now I need to execute, but before that I will execute line 3 and I will print 6. Okay, so 6 is printed here, if you can see, and now execute line 4, which will call in order with node 7. Okay, so node 7 now becomes colorful, it says that okay, now I am going to be executed node 7, L2 it executes L2 in order x left, so nothing is there, it returns back here, it prints then 7. Okay, so it prints 7 and then it tries to go to line 3, is done. Line 4 it goes x dot right, which is 13, now it goes to 13. Okay, so from here if you see, so it goes to 13. In 13 now I7 has L4 executed, it goes to I13 in order 13. So now in order 13 is not null, so this node is not null, so it will, now what it will do, it will go to its left child, which is 6, which is 9 basically. Okay, so I had some printing mistake here. So it was actually 9. And then what happens is at 9 it prints itself, left and right child were null, so it just prints itself, comes back to 13, and now 13, at 13 L3 is executed, it's printed here, and it now tries to call in order node right, which is null. So this is done, and then it goes back to 7. Okay, so 7, its right child is also executed, so line 4 in order x right was executed with node 13. This also returns, so this is popped out from the stack. I6, this has also executed all its lines, in order x right has been executed, it pops out. I15, it goes, now this one has executed till in order, and then it prints its value. Okay, 15 is printed here. Okay, so if you see 15 is printed, and now it's time to call the in order x right, which is 18. So 18 is called, 18 now is on L2, this is not null, in order x left, so it calls this one. For this node 17, it's not null, but its left child is null, it returns back, then it prints 17, and then tries to go to in order right, which is null, returns back and returns to node 18. Okay, so I7 L3 is 17, L3 is done, it prints itself. Okay, and then I17 is done, and it goes to I18. Okay, so let's see, I18, it's here, so there's no color here, but I'm at 18 and left node traversal is done. So now what I need to do, I need to traverse the right node, so which is 20. So I call I20 L2 line, and it in order is null, so it then prints itself out. Okay, and after that 20 is printed, and then before that in fact 18 should have been printed. Okay, here, so after 17, before going to 20, 18 should have been printed, which I forgot. Okay, now 18 is also done. Okay, and from 18, now its right child is printed, so it returns back to node 15. Okay, so it returns back from where it came, and now all its lines have been executed, so it just ends. So the answer is 2, 3, 4, 6, 7, 9, 13. Okay, and then 15, then 17, and then 18 is missing, which we should have printed, and then 20. So this is done, this is the answer. And one thing more is that if you have a binary search tree, in order traversal gives an increasing order listing. Okay, so I will just correct the answer. This is a 17, after that 18 is missing, so it is 15, 17, 18 and 20, which I had missed. Okay, so this is the way in order traversal works. So I hope you understand this. Thanks a lot.